All right, it is Thursday afternoon, the day before International Day. The holiday is just about here. You may want to just sit back, relax. Your teacher isn't here, so you just want to hang out and get nothing done. Sounds like a good idea? No. Today's lesson is pretty important, and it's one that most students find kind of difficult. So I've made this video to help you out. Since I'm gone, I feel bad that I can't be there to support you. So this video is here to help you learn what you need to know for a topic that many students find kind of tricky. So I'm going to help you as much as I can. Let's get started. You will need the worksheet that the substitute or cover teacher has given you. If that worksheet is not available from the teacher, just have somebody print it and make copies for the whole class. All right, grab the worksheet. Let's get started. So let's take some notes. On top of your worksheet, it says simplify this expression. So we're going to begin with what you've been doing last, which is indices and using the laws of exponents or laws of indices. So looking at this one, you can see there's a 25, a 5, and a 125. Right away, I hope your mind was thinking, wait a minute, those are all things that can be changed to 5, like this is actually 5 squared and this is 5 cubed. And if you're thinking that, that's good because that's exactly how we proceed with this one. We cannot combine anything until the base is the same. The bases are right now 25, 5, and 125. We can't combine those. We can't use the rules of exponents. We cannot use the rules of exponents until these bases are the same. So let's make them the same. So check it out. Look what happened. This 25 is actually 5 squared. So I replaced this 25 with 5 squared, and I kept this 2n out here. So that's the only change that was made. This thing became 5 squared. Over here, it's already a 5, so we're going to leave it as it is. On the bottom, I have 125 to the power n. 125 is 5 cubed. That means 5 times 5 times 5. So I'm going to replace this 125 with a 5 cubed. All right? So 5 cubed, and there's all these parentheses because it's 5 cubes to the n, and then that is to the power squared, right? So I've rewritten it. All the bases are now the same. Now we can move ahead with the laws of exponents when the bases are the same. So first of all, when you have this exponent, parenthesis, another exponent, you multiply those, remember? And let's do that. So notice 2 times 2n has turned into 4n. This one, I've left it as it is. This one, you're going to use the multiplying rule also. So 3 times n, and then that times 2. So it's like 3 times n times 2, which is 6n. All right, so that looks a lot simpler than what we had here. That's good. All right, so we have this. We have the same base. We're almost there. Now we're going to use the rules of exponents about combining things. So here, multiplying means you're going to add these, right? You add the exponent. When you have multiplying, you add the exponent. So I'm going to do 4n plus 1 minus n. I'm adding this exponent to this one. There it is. The bottom remains the same. So now I'm going to simplify this by combining that. All right, that becomes 5 to the 3n plus 1, because 4n minus n is 3n, and then we have this plus 1. So there it is. Wow, we're almost there. We have this now. Now the rule when you have division is to do what? Well, I think when you have division, you're going to subtract, right? You subtract exponents. So you're going to do this one minus this one. All right, over here, we added, but here we're going to subtract. So let's take a look at that. There it is. That exponent minus that exponent. I know this is a little bit different than the ones we did because there's all these n's and things, but the same rules apply, right? So just think of it that way. It doesn't matter if it's just 5 squared times 5 cubed and you'd add those. It's the same rules that apply here, all right? So now we're going to subtract those and you get this. 5 to the negative 3n plus 1. So this has been simplified fully. All right, lots going on there, but you know all the rules. You have the tools to do this. You just got to do it, all right? Let's look at the next thing. So now, the topic is solving exponential equations. So now, all of a sudden, everything until now has been an expression. There's been no equal sign. There's no final answer from it other than a simplified form. But now we have an equation, and we have to solve the equation. So that means we're going to get an answer for x. Let's begin with a really simple one, but I'm just going to use it to use it to highlight what's going on here. This is simple. This is just a linear equation. To solve for x, we're going to divide both sides by 8. So 4 over 8, which can be simplified to 1/2 if you want. Now oh, there's the 1/2. Now let's look at the one beside it. That was a linear equation. This is, whoa, what's going on here? This is called an exponential equation because The exponent is a variable. This is an exponential equation. This one, well, this one was easy to solve. This one, well, how do you solve it? How do you figure out that x is? This is kind of strange. Now, the technique we're going to use for these ones is exactly what we did in the last question. If we can just get the bases to be the same, then we can really move forward with this. So you're looking at 8 and 4, and you're like, what number is kind of common to those? Well, if you turn this into a 2 and this one into a 2, we would have the same base. So here's what I mean. 8 is actually 2 cubed. It's 2 times 2 times 2. So 8 is actually 2 cubed. So that 8 has been replaced by that to the power x. 4 is actually 2 squared. So there it is. So now we have this. We have the same base. That means we can really move forward with it. Now, this rule here tells us we're going to multiply those. So we're going to get 2 to the 3x equals 2 squared. We're almost there. Now, the way to look at this is to think, wow, 2 to some power equals 2 to squared. So if these two things are actually equal to each other, then this exponent must be equal to this exponent. It's the only way this will actually be equal. So let me show you what I mean. We can now just jump from this to this. We know that if these two things are going to be equal to each other, then the exponents must be equal to each other. So 3x must be 2. And that's the only way they'll be equal. Because if 3x was not 2, then these two things would not be equal. So 3x equals 2, solve that, divide by 3, x equals 2/3. Alright, so now imagine putting 2/3 in here. So replace this x with 2/3. So when you have 2/3 in here, do you remember what that means? It means take the cube root of this and square it, right? So again, put 2/3 in there. Cube root of 8 is 2. Square that, 4. So it works. It works out. Alright, it works out. Great, let's look at the next one. Oh, so yeah, let's highlight that rule. Make the bases the same, then solve. This is a key to these problems you're going to be working on today. This is what today is all about. Make the bases the same, then solve. Alright, so there's the same base. Alright, here's the next one you have on your page. Okay, a little bit trickier. There's a fraction here, but you're looking at this one. I see a 3, and I see a 9 here. And you're like, can 3 and 9 be made the same? Well, they definitely can. Check this out. 3 to the x stays the same, and 1 over 3 squared, because now we've made the bases the same. 3 squared is 9, so that's fine. We've rewritten it in a different form, and we have the same base. Once we have the same base, things will work out. You'll see. Alright, so this is still no good. We have a fraction, but you remember the rule. When you have this and you want to bring it up, what happens to this 2? The 2 becomes negative. So this is now this. So now we're at the same spot we were last time. We have two things equal to each other, so in order for these to actually be equal, the exponents must be equal. So x must be negative 2. So now again, imagine putting a negative 2 in here, then those are really equal. If you put anything other than negative 2 in here, these would not be equal to each other. So x is negative 2. Next one. Alright, a little bit more going on here, but we're going to use the same approach. I see a 2 here, and the base here is a 4. Can you make these bases the same? Well, hopefully you're thinking, yeah, this 4 can be turned into a 2. And basically, a 4 is actually a 2 squared. So I'm going to replace this 4 with a 2 squared. And then out here I still have x plus 2. So now I have the same base, 2 and 2. Alright, when it's the same base, it becomes easy. But first we're going to multiply this to combine those. 2 times x plus 2, because the rule for that is multiply. So this one stays the same. This one I've multiplied that 2 times x and 2 times 2. So 2x plus 4. Don't make the mistake of writing 2x plus 2. That would not be correct. You have to multiply both. Both of these are multiplied. So here, now we have this. Alright, good. So same base. Now we have an exponent. The only way these two can actually be equal is if this exponent is equal to this exponent. So we're going to rewrite that as this equation here. So this exponent equals that exponent, and then therefore that will be equal. So now solve this. Alright, I'm going to subtract 2x from both sides. Right, minus 2x minus 2x. Then I'm going to add 1, and I have an answer for x, 5. Let's double check that that works. X equals 5. Put a 5 in here. Alright, 3 times 5, 15 minus 1 is 14. So this is like 2 to the 14th power. And here, put in a 5. 5 plus 2 is 7. So it's 4 to the 7th power. Interesting. Are those really equal? I don't know. Well, let's put it in here and check. Let's try again. Put a 5 in here. 3 times 5, 15 minus 1, 2 to the 14 power. And here, put in a 5 also. 10 plus 4, 14, 2 to the 14th. So when you have a 5 in there and a 5 in there, it's 2 to the 14th equals 2 to the 14th, and it works. So x equals 5 is a good answer. Excellent. It's time for you to, oh no, not yet. There's one more example. All right, this one. This is a different kind of thing. This is, look at this one compared to the last ones. It's not the same. The exponent is not the variable. The x is down here. So this is not the same process because we are not dealing with an x in the exponent. The x is down here. Our goal here is to get x by itself though. So you want to get rid of this. If you can get rid of this 3 over 2, then you'll have x by itself, and then you'll have an answer for x. You'll have x equals something. So how do you get rid of that? Well, check out this easy way to get rid of any exponent like this. All right, all I've done is taken that first one, and I've applied this reciprocal exponent to it. So see this? This is the reciprocal. It's the flipped over version. And if I'm doing that on this side, you know when you're solving equations, what you do on one side, you do on the other side. So I'm putting this exponent on both sides. Why did I put this exponent here? Well, the rule is when you have this exponent, parenthesis, exponent, you multiply, right? And when you multiply those, 3 times 2, 2 times 3, you get 6 over 6, and that's just a 1. So this turns into 1. All right, so it's just x to the 1 equals 8 to the 2/3. So x to the 1 is just x. This has allowed us to get us back down to just x, which is what we want. We want to solve for x. All right, now we got to figure out what 8 to the 2/3 is. Hopefully you're pretty quick with this stuff now. This means take the cube root of 8 and square it. Cube root of 8 and square it, right? Cube root of 8 and square it. Cube root of 8 is 2. 2 squared is 4. So our answer is 4. All right, those examples that we just did will help you do all the textbook homework. All right, textbook homework will be given to you at the end of this video. For now, I do want you to try a few more. So there's a few more on your page. Let's just try these. It begins with this one. So pause the video, or actually it's going to pause for you, I think. And what is your answer for here? You got to solve for x. These are a little bit harder maybe than the ones we just did, but work with somebody, work with your group, see if you get an answer, and then answer the quiz, the answer that you got. All right, now that you've selected your answer, let's take a look how it's done. This one, again, the goal is to make the same base. Here's a 4, I'm going to make this a 4. So it's usually taking the bigger one and making it into the smaller one, right? 64 is 4 cubed, because 4 times 4 times 4 is 64. So now I have the same base, all right? When you have this, remember, you're going to multiply those. So that becomes this times this, all right? Multiplying equals that. Now I'm going to multiply through here and see what I get. That becomes x squared plus 2x equals this. Okay, so again, we have the same base, and now we have exponents. So in order for these to be equal to each other, this exponent must equal this exponent. So x plus 2x must equal 3. That's the only way this will be true here. So now that I have that, oh my goodness, it looks like a quadratic. Okay, well, it's not so easy to solve that. It's not like just a linear thing. It's quadratic. To solve a quadratic, we need to move this over here. The 3 moves over there, and we get 0. Right? Now you look at this, you're like, hey, if I can factor that, then I can solve it. And yeah, this one does factor. You think about that, you can factor that into x plus 3 times x minus 1. That will give you two answers, x minus 3 and x equals 1. So our two answers for this one are these. Now check to see if it works. X equals negative 3. Put negative 3 in here, negative 3, put negative 3 in here. You get negative 1. Negative 3 times negative 1 becomes 3, so this becomes 4 to the 3rd power, which works. All right, now try 1 in there. Put a 1 in here, put a 1 in here. It ends up being 1 times 3, which is 4 to the 3rd power, which works, 64. All right, so these answers make sense. Here's the next one you should try. All right, trickier. They're getting trickier and trickier. So this one, we have this. Okay, I look at this, I'm like a base of 2, base of 2. Oh, can I make a 16 into a 2? Yeah, definitely. 2 to the 4th power is 16. 2 times 2 times 2 times 2. Good. Now I have all the same base. That's great. I should move this up though. We don't want fractions, so move this up. When you move that up, that becomes negative 4, right? That goes up, this becomes negative 4. Almost there, look at this, all right? The same base. However, I gotta combine these. I need just one exponent, and to combine these. So the rule here is when you multiply, you're going to add those exponents, right? When you multiply, you add them. So that becomes that, x plus 1. I'm adding those two exponents. This remains the same. Now I'm going to combine those to simplify it. That becomes 2x plus 1. Now I have that situation where I have 1, 2 to some power equals 2 to some power. The only way for this to be true is if this power equals this power. So 2x plus 1 must equal negative 4. Solve this equation. This one's not quadratic, so easier than the last one. I'm going to subtract 1 on both sides, so minus 5. I'm going to divide by 2. X equals negative 5 over 2. That's our answer. If you want to check, you can put that exponent in here and here. So I put that x value in here and here, and you'll see it works out because this will end up being 2 to the negative 4, which is the same as this. Alright, next one, or last one for you to try is this one. Great, now that you've tried it, let's take a look. This one, we have a fraction. Again, you don't want fractions. We're going to bring this 9x up, so when that comes up, this becomes negative x. Alright, a couple more things to do. I see a 3 here. That's our smallest base. So my goal is to take this bigger 9 and this bigger 243 and turn those both into 3's. Alright, 9 is actually 3 squared. 243, you got to remember these basic ones, like 3 times 3 is 9, 9 times 3 is 27, times 3 is 81, times 3 is 243. So 243 is actually 3 to the 5th power, so that is actually that. So here we have this, then 3 squared, which replaced the 9 with the negative x out here, and that. Alright, now I'm just rewriting this. This 3 is actually 3 to the 1. I just want the 1 there for the next step. This, when you have these parentheses, you multiply the exponents. So I multiplied 2 times negative x. Now we're going to look at this, and we need just one thing on this side, so we're going to combine those. And the rule here, when you're multiplying, you're going to add the exponents. So 1 plus negative 2x, you're combining these two exponents. That stays the same. Combine these, simplify, 1 minus 2x, that. Now we're back down to the basic equation. 3 to some power equals 3 to some power. That means this exponent must be equal to this exponent if these are actually equal to each other. So 1 minus 2x must be 5. And solve that. 2x equals negative 4. Divide by 2, x equals negative 2. Alright, excellent. Let's check that one. That's an easy one to check. So negative 2. Put a negative 2 in here. Negative 2. Okay, so 9 to the negative 2. That means you can bring that up, and it'll be a 9 squared here. So you have 3 times 9 squared. 9 squared is 81. 3 times 81, 243. It works. It's amazing. All right. Excellent. With that, you should have a pretty good set of examples to work with, and you're ready to do the assignment. Please work with your group today. You can do it. The practice is begin first with the textbook sections. All right. Textbook sections are page 108 for D and 109 for E. Yeah, use the same kind of approach we just did. Work hard, you can do it. Don't let this time slip through your fingers. Get this done with your group. It will be assumed when you return from the break that this is done and you have an understanding of it. So do that. Then, if you're done that, go to the back of the worksheet you were just taking notes on. There's a lot more problems for you to try there. All this must be done when you return from the break. All right, good luck. You can do it.